All right, good morning, guys. Sorry I'm not here to go over today's lesson with you. I've got sick kids at home, so you're going to have to deal with this version of me today. We're talking about complex numbers, which is really just another number set. I mean, when you started learning numbers, you started with the natural numbers, which were 1, 2, 3, just those counting numbers. And then we introduced you to whole numbers, which are, if you notice, the whole number circle includes the natural numbers because it's all of the natural numbers, but we also add one extra, and that is 0. Then in 7th grade, we introduced you to integers, which again, integers include natural numbers, whole numbers, and you get -1, you get -2, you get -1,375. Negative whole numbers are part of the integers. That year, we also introduced you to rational numbers, which were numbers that you could write as an integer over another integer. So like 1/2 or 7/9 or 1.4, or repeating decimals like 1.3 repeating. Those were rational numbers. And then sometime in middle school, you learned a little bit about irrational numbers, probably not a lot, but they're kind of over here all on their own. Irrational numbers are things like pi or the square root of 2. Those, they're decimals that never end. They just go on forever. That is an irrational number. Now, all of these are part of a bigger group called the real number system. So all of these are special real numbers, but outside the real number system, we have an even bigger set. So this set includes all our real numbers, but this set is called complex numbers. So all complex numbers, well, I guess not all complex numbers. Natural numbers, whole numbers, integers, rationals are all a complex number. And complex numbers are numbers that we have kind of made up. We have this imaginary unit called I. It's a complex number, and what's imaginary about it is that this number works so that the square of this number, so if I take I squared, my answer is -1. I squared is equal to -1. That means that I is the square root of -1. And that's not a real number. It doesn't exist because anything times itself is a positive. But we invented this number I so that when you multiply it by itself, you get a negative. And we did this because we ran into a lot of places in math where we had to take the square root of negative numbers. And that was impossible to do. So rather than give up, we just made up numbers. We just made up stuff. So if you have a, the square root of -a, we shouldn't be able to do. But with our new imaginary number, I can change this to the square root of -1 times a. So -a, I just changed to -1 times a. And then I can use my rules of radicals to change this to the square root of -1 times the square root of a. And because now I know the square root of -1 is I'm left with the square root of a multiplied by I on the outside of the square root. So that's square root of a multiplied by I. So that's my answer to what is the square root of -a. It's just the square root of a multiplied by this imaginary number. So in this example, square root of -5 becomes -1 times 5, which becomes the square root of -1 times the square root of 5, which becomes I times square root of 5. But we usually write the I second. We usually put square root of 5 and then I on the outside. It doesn't go underneath. So square root of 5, I becomes my new answer. So I've got somebody knocking at my door. I'm going to pause. Okay, back to what we were talking about. So just a little note here. If I take the square root of -5 and I square it, that becomes, that turns into I times the square root of 5, which we did right here. And I have to square all of that. So that becomes I squared multiplied by the square root of 5 squared. And I squared, that's the square root of -1 squared, times the square root of 5 squared. And this square root and the square just cancels out. So this becomes -1 times 5, which equals -5. So it does some really cool things we weren't able to do before. We've never been able to do something with a square root of a negative. We just said, oh, sorry, there's no such thing. It doesn't exist. Now, because of this imaginary number, we can. And I think that's pretty cool. You make stuff up and now you can do math. We need to be a little bit careful about what we make up. Some of you make up math sometimes and it doesn't work out so good. So here's a couple that we'll do. We want to write this as an imaginary number, square root of -12. So that becomes the square root of -1 multiplied by 12, which we can actually break down to 4 times 3. So this becomes the square root of -1 times the square root of 4 times the square root of 3, which is equal to square root of -1 is I, square root of 4 is 2, and square root of 3 is just square root 3. So our answer would be 2 root 3 times I. Okay, simplify this one. Square root of -25. If you're getting the hang of this, you know that that just becomes I times the square root of 25. That negative just comes out front and turns into an I. But we also know the square root of 25 is 5. So this becomes 5I. And that's your final answer. So expanding on this idea of imaginary, of complex numbers. A complex number is made up of, it's in this form, A plus BI. And A is usually not, it is the not imaginary part, and B is the imaginary part. And this is why all of those numbers, the integers and the whole numbers, are technically complex numbers, because if A is 1/2 and B is 0, then I have 0 i's. So this just becomes 1/2. But it still can be written like a complex number. We just don't have any i's. If we have a number that is where we don't have an A, where we just have like 3i, we call this a pure imaginary number. Nothing that you need to stress too much about memorizing, just something I want you to be aware of. So we have to combine, we have to add and subtract complex numbers. And when we do that, we combine the real part and we combine the imaginary part separately. What that means is, in this example, here's one complex number, 7 minus 2i, and I'm going to add another complex number, -3 plus I. What this says is I can't add imaginary numbers to regular numbers. So when I combine these two together, I'm going to combine the real numbers together, and I'm going to combine the imaginary numbers together. So this becomes, I just take the real part, 7, and add the other real part, plus -3. And then I do the same thing with the imaginary parts. I take -2 i's, and I'm going to add 1 I. So when I add together this part, 7 plus -3 is 4. -2 plus 1 is just -1 I. So when I add those complex numbers together, this becomes my new complex number. Okay, it's just like terms. The I terms are like terms. You can add them together. You can't add them with other terms with a different variable. So on this one, 1 plus 5i minus 3 minus 2i. So I do 1 minus 3. I do the real parts. And then I do the imaginary parts. 5i minus negative 2i. Don't forget there's a minus minus here. So 1 minus 3 is negative 2. 5 minus minus 2i is 5 plus 2i, which is 7i. And there's your new complex number. All right, so down here, why don't you pause the video and try these two on your own. After you've tried them, come back and make sure you did them correctly. So what you should have done on this first one is 8 minus 8, which is 0, and 6i minus a negative 6i, which is 6 plus 6i, sorry, 6i plus 6i becomes 12i. So that becomes your answer. There's no real part to that one. And on this one, negative 3 plus 3, you should have combined those and got 0. And 9i plus 9i should have given you 18i. Again, these are just like variables. When I add them together, this doesn't become I squared. It's just I have 9 i's and I'm adding 9 more i's. So be careful not to change the variables when you're adding or subtracting these. However, when we multiply them just like you would FOIL any other binomial. Okay, so we treat this binomial as we would 2 plus 3x or x squared plus 7. We do the exact same thing that we would do in this situation. I would take my a times my c, and then I would take my a times the di, so that would be a times di. And then I take the bi times c, which becomes cbi, and then I take the bi times the di, which becomes bdi squared. So let's do a couple examples, then I'll let you try it. So we just FOIL. 2 times 4 is 8. 2 times 5i is 10i. Negative 3i times 4 is negative 12i. And negative 3i times 5i is negative 15i squared. Be careful, when you multiply them, your variable does change because you have I times I, which becomes I squared. Now, here's where simplifying gets a little bit different, because right now we want to combine like terms. 10 i's minus 12 i's. So this becomes 8 minus 2i. And then I have minus 15i squared. But I'm not done yet, because I squared simplifies. Remember, I is square root negative 1, square root of negative 1. When I multiply those together, this turns into negative 1. So I actually get 8 minus 2i, and then negative 15 times a negative 1 is a positive 15. Now I've got constants to combine, 8 and 15. 8 plus 15 is 23. And then I have this negative 2i out in front. So that becomes negative 15 plus, negative 2i plus 23. I guess if we want to write it in the normal complex form, we would do the regular part first. So I should probably do 23 minus 2i. On this one, 7i times 3i, that's just 21i squared. I squared equals negative 1. That might be something you want to remember and write down somewhere. So this is 21 times negative 1, which is just negative 21. All right. So go ahead and try these two on your own. When you're done, hit play, and we'll see how you did. All right. Negative 4 times negative 4 is 16. Negative 4 times negative 5 is a positive 20i. Then I move to the insides. 5 times negative 4 is a negative 20i. And 5i times negative 5i is negative 25i squared. So my 20 and my negative 20 cancel out. So I have 16 minus 25i squared. But I squared is equal to -1. So this is 16 minus 25 times -1. Please multiply before you subtract, because that actually becomes 16 plus 25, which equals 41. So when I multiply these complex numbers, I end up with just a rational number, just an integer. On this one, 9 plus 4i times 9 plus 4i. 9 times 9 is 81. 9 times 4 is 36i. And then I have another 36i. And then 4 times 4 is 16. I times I is I squared. So 81 plus 72i plus 16i squared. But the I squared becomes -1. So 81 plus 72i plus 16 times -1 becomes 81 plus 72i minus 16. So I can combine these and I get 65 plus 72i. So when I multiplied these binomials, I ended up with another complex number. All right. So now let's apply this to something that actually matters right now in this unit and what we're trying to do. We found that if our graph, if x squared minus 6x plus 10 does not cross the x-axis right here, we said there are no real solutions. That's different than there not being any solutions, because technically there are solutions. They're just imaginary. What we kind of do is we imagine that if we were to flip this over, we cross the x-axis right here and right here at -2, or sorry, at +2 and at 4. I can't just say that my answer is 2 and 4, because it's not. This is imaginary. This is an imaginary graph that I made up. So we have to go through some steps to figure out, in the imaginary world, in our made up math world, what are these two values right here? They're not 2 and 4. They fit a different set of rules. So the easy way of doing this, rather than flipping this over, going through a whole bunch of messy coming up with formulas, first of all, we just simplify the quadratic equation. So here's my equation that I started with: x squared minus 6x plus 10. When I set that equal to 0, there are no real solutions. It never crosses the line. So let's find these fake solutions. First of all, a equals 1, b equals -6, c equals 10. So I plug those into the quadratic formula, okay, into the quadratic equation. And I'm going to put formula right here, because sometimes when I say equation, you're not sure what I mean. So we're talking about that formula. X equals -b, which is -6, plus or minus the square root. I know some of you are already cringing because you hate writing this out. Too bad. Write it anyway. B squared, -6 squared, and don't be lazy and forget your parentheses, times or -4 times a, which is 1, times c, which is 10. And then I divide all of that by 2 times a, which is 1. When I simplify this, -6 becomes +6, plus or minus. If I plug this whole thing into my calculator, -6 in parentheses squared minus 4 times 1 times 10, if I plug it in exactly like I wrote it, I end up with the square root of what? 36 minus 40, which is the square root of -4. And all of that divided by 2. Normally right here, you would tell me there are no real solutions because of that square root of -4. But now with our cool imagination, we can change that. So that's what we do. We change our negative square roots. We change those to imaginary numbers. So this becomes 6 plus or minus. Instead of the square root of -4, remember, square root of -4 is equal to the square root of 4, and I just pull the -1 out front and turn it into an I. And that equals square root of 4 is just 2. So that becomes 2 times I. So this whole thing, square root of -4, becomes square root of 4 times I, which becomes 2 times I. So this becomes 2 times I divided by 2. So step 3 is I just finished simplifying. 6 plus 2I divided by 2 and 6 minus 2I divided by 2. I need you to be careful because some of you are going to want to do 6 plus 2. But remember, I can't. I can't add 2 to 6. But I can divide, because 6 divides by 2 and 2 divides by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So my answer over here becomes 3 plus I. The complex number 3 plus I is what x equals for this fake imaginary solution. This one, 6 minus 2I divided by 2. Again, I can't minus 2I from 6 because that's an I, and this is a constant. But what I can do is divide by 2. 6 divided by 2 is 3. -2 divided by 2 is -1I. So this just becomes 3 minus I. And that's my other imaginary solution. Again, it's not a real solution. It is a solution. If I plug 3 plus I into this equation, I get 0. If I plug 3 minus I into this equation, I get 0. In fact, I challenge you to plug those in and try to FOIL and distribute and work that out and see how you end up with 0. Okay? Let's try one of these, just all by itself. I'm going to do the one on the left. The one on the right, you have to change into standard form. I'll let you do that by yourself. This one's already in standard form, so I want to do that one. A equals 3, B equals -1, C equals 2. So x equals, I'm looking for solutions. I don't know yet if they're going to be real, imaginary, one solution. All I know is I want to use the quadratic formula. I don't want to factor that. So x equals -b, which is -1, plus or minus the square root. B squared, again, -1 squared, minus 4 times a, which is 3, times c, which is 2. All of that is divided by 2 times a, which is 3. So when I simplify, -1 becomes 1. Plus or minus, if I put -1 squared in parentheses minus 4 times 3 times 2 in parentheses, if I put this in my calculator, I end up with the square root of, that's going to be 1 minus 4 times 3 is 12 times 2 is 24. 1 minus 24 is -23. And all of that gets divided by 2 times 3, which is 6. So here's where I kind of get stuck because I can't do the square root. So there are no real solutions. So let's look for imaginary solutions. Instead of square root of -23, I'm going to change that to 1 plus or minus. That negative I'm going to pull out in front as my I. And square root of 23 is just square root of 23. And then that is all divided by 6. So I have 1 plus the square root of 23 i's divided by 6, and 1 minus the square root of 23 I divided by 6. Make sure you don't put that I underneath the square root on accident. It needs to be next to it. If it helps, put it in front of the square root. I usually like to put the I at the end of the number instead of in front. But really, it means the same thing. Some people like to put the I out front because they remember, oh, that means that this isn't just a 5. It's a 5 times an imaginary number. Doesn't matter to me. As far as your answer goes, this would be them. Square root of 23 doesn't give you a nice number. Okay? It gives you some, well, let's see. It's going to give you like 4.7 or 4.8 or something like that. So it's not a nice number. You could figure out what it is. This right here, if the computer asks for an exact answer, this is what you would put. Okay? If the computer wants a decimal, then what you have to do is you have to divide everything by 6. So this would become 1/6 plus the square root of 23 divided by 6, I. And when you divide, you're not going to get, again, you're not going to get very nice numbers. So I'm pretty sure the calculator, or excuse me, the homework program is going to like these answers more than it's going to like this right here. Because this is one ugly decimal plus another ugly decimal times I, whereas this is an exact answer, just like it is. If I knew the square root of 23, I would simplify it further, but I don't, so I'm not going to. So go ahead, pause the video, give this one a shot. Remember, it needs to be in standard form first, and good luck. Okay, let's check your answer with what I got. X squared plus 2x. To get this equal to 0, I have to add 3 to both sides. So this gets plus 3 equals 0. So A equals 1, B equals 2, and C equals 3. So when I plug those in, X equals negative B, so negative 2, plus or minus the square root. Yes, I still put it in parentheses because it's a habit, and I don't want to lose that habit, of b squared, which is 2. Again, I'm going to use the parentheses even though it's positive, times 4, or minus 4 times 1 times c. All of that gets divided by 2 times 1. So x equals negative 2 plus or minus. If I put 2 squared minus 4 times 1 times 3 in my calculator, just like this, I'm going to end up with my square root, and the underneath part becomes 4 minus 12, which is negative 8. All of that divided by 2. So here's where I want to get rid of this. There's no real solutions. So my imaginary ones, I'm going to change this to plug in an I. So x equals negative 2 plus or minus. Instead of the square root of negative 8, I want I times the square root of 8 divided by 2. This one we can do some simplifying because the square root of 8 is really equal to the square root of 4 times 2. And I know what the square root of 4 is. So the square root of 4 times the square root of 2 becomes 2 square roots of 2, which is a very popular number as you get higher in math. That's going to come up a lot. So this right here becomes negative 2 plus or minus. Instead of square root of 8i, I have 2 roots 2, 2 square root 2i, all divided by 2. So negative 2 plus 2 root 2i divided by 2, and negative 2 minus 2 root 2i divided by 2. Please don't add these together. You can't. This one is being multiplied by I, so it has a different variable. But what I can do is divide everything by 2. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. So this becomes negative 1 plus positive 1 square root 2 I. And my I is outside the square root. On this side, negative 2 divided by 2 is negative 1. Negative 2 divided by 2 is still negative 1. So that's negative square root 2 I. Those are the answers that you should have got. This is going to come up. You're going to see it on the test. You will see this on the ACT. It loves not real solutions. It loves this complex imaginary number stuff. So go on to homework number 10. Remember that it's due on Thursday, so make sure you get that done. If you have any questions, email me or use the Get Help button. I'll do what I can. And if you get bored, try something for me. I equals what? I squared equals what? I cubed equals what? I to the fourth equals what? I to the fifth equals what? I to the sixth equals what? Keep going. Maybe up to 10 or 12 or 15. I equals square root of negative 1. I squared equals square root of negative 1 times the square root of negative 1, which just equals negative 1. I cubed is the square root of negative 1 times the square root of negative 1 times the square root of negative 1, which equals negative 1 times the square root of negative 1. Keep going and see what these simplify to if you get bored. Otherwise, good luck on the homework. Sorry I missed you today. Hope you all have a great time. See you later.